I should go visit him. So he's like, we got a foot of snow last night. A foot? It never snows. In fact, when it rains 2 weeks out of the year in my hometown, and when it rains, usually they close school for rain because nobody knows how to drive in rain because, well, we live in California and, well, on the coast in California specifically, and nobody knows how to drive. Okay. So we do when the weather's great, but, you know, if there's a little bit of anything on the roads, like, forget it. Okay. All right. So it looks like we are live here. Let me make sure we have audio also. Yep. Okay. Looks good. Good. And let me check the last one. All right. Give me a thumbs up for no echo. Thumbs down, there is an echo. Thumbs up, we're looking good. Okay. So let's get our... Get our questions box up. I'm excited for vacation. I mean, I wish I could. One time actually I taught straight through Christmas. I think 2 years in a row, like through the whole holiday. I was still teaching classes every single week. And some of the parents were like, "You're crazy," and the other parents were like, "Thank you so much." Okay, all right. Well, hello. Give me just a second, and we will start our class. All right, hello and welcome. This is Aurora. We're a couple of minutes early. Hi. So I actually do you guys know what toothpick puzzles are? Yeah, so all right, so I made a couple of toothpick puzzles. Do you want to see them while we have a few minutes? All right, so we are going to finish up our decimal session in just a minute, but I made them out of matchboxes. You can see them here. There is a bunch of them. And when here's one, it's called Rudolph's Nose. And then when you open it up, well, you can put toothpicks in here. It has like a little puzzle. This one's called a little donkey. And then you're supposed to make it out of, it looks like there's two puzzles in here. You're supposed to make it out of the matches and then the toothpicks. And it says, move one matchsticks to change the direction of that the donkey is facing. Just move one. And then there's another one. Looks like there's another one at the bottom. Oh, here's Rudolph's nose. Rudolph is facing left. Move just two matches so that Rudolph can now face right. But you can look these up online. So I made a bunch of them, and when our family is like at a restaurant and we're waiting for something, I'll pull these out, and then we can play games like that and stuff. Aren't those fun? You want to see another one? Here, sleigh bells. This is the one. Oh, there's two in here as well. This is the one. Let's see if we can get the sleigh bell one. Oh, this is the triangle one. I think this is the one that was more challenging. It says, so you can see I've got 3 made out of 3. Anyway, you could make up your own as well. You don't have to use somebody else's, but there's a whole bunch. What do you guys think? Do you want me to take a picture of these and send it to you? Would that be interesting? Would you guys like one of those? That'd be fun. A little bit. Oh, I see some smiles. Okay. So yeah, the idea is not to play with matches. Who said that? I saw that comment fly by right now. No. So use toothpicks, especially if you've got small kids around. Just use toothpicks. Okay. Shall we get started? Yes. All right, let's do our official start. Rev up your engines and give me a great big oh yeah, because I have got a big oh yeah story for you today too. You ready? 3, 2, 1. Hello and welcome. This is Aurora with Supercharged Math, and we made it. You guys should be cheering right now. Yay! We made it through a whole term. You guys did fractions, you did decimals, you put up with me and all my stories, and you did a ton of work. How do you feel? If you look back to September, how are you feeling? You feeling like you learned a lot? Yeah, maybe you wish you had more time to spend on some of this stuff. Or maybe you're feeling like, I'm ready for a break. So today's class is going to be a little bit different. If you downloaded the handout, you probably noticed it doesn't look like the regular handout. A couple of quick announcements. So if you have the handout for today, it's going to make your life a little easier. If you don't, I'll show you where to download it, so after class you can do that. But just grab your math journal and you'll be just fine. but it will be nice to have the word problems as well. Okay, so for today's session, can you write these dates down for me on your journal? Who's coming to my party? Anybody coming to my party? Yay! Aurora's having a party, and it doesn't say when. What did I do that for? Okay, so we have a master calendar. Here, let me pull it up. All right, here's my master calendar. So right now we are on math grades 4th through 6th. We're going to be doing decimals. And then at 10, I've got that. So the party is over here on Wednesday the 13th at 4 p.m. Pacific. So that's 5 Mountain Time, 6 Central, 7 Eastern. So let me see. I could probably fix that really quick. So yes, Aurora's having a party. Yay! Okay, review. Let's see. Let's just say Aurora's math party at, I'm going to say December 13 at 4 p.m. And you will need a handout for that one. You will need a handout. So I sent it to you already by email. And so if you didn't get it, let me know so I can be sure to send that to you. We're going to spend an hour escaping the class and just having some fun. All right, speaking of fun, how about we work on some problems today? So you actually already know everything there is to know about decimals. You know how to add, subtract, multiply, and divide. And so what we're going to be doing today is putting all of that together, and then you get to tell me when we do these things. So for example, if I said, hey, I've got $3 and you've got $2, together we have, everyone shout it out, 5, see? Not that hard, all right? All right, and then you took my money, we put our money together, you took it and then blew it all on ice cream. So is that addition, subtraction, multiplication, division? Yeah, $5 minus $5 is 0, so that's a subtraction problem. See, not that hard. You already know how to do it. Shall we do it for real? Yes. All right, big smile on your face. All right, here we go. We are gonna go and take a look at the handout. This one says baking cookies. Has anybody been baking cookies this time of year? Yeah, cookie baking tends to be kind of popular. Okay, so here we go. This is actually a problem we had for real. So each batch needs, so we're gonna bake some cookies. We're in the kitchen. Here we go. So I would actually put you in a kitchen and then ask you this, and then you would have to figure it out. So each batch needs, how much is that? Do you see that? Here, 0.25, that's how many cups of sugar we need to make that much sugar. Cups of sugar make 18 cookies. Okay, so now we know, so this is a 1/4 cup sugar. That makes 18 cookies. Guess how many cookies we have to make? Everybody gets one. This is your, this is a present you're making for people. We have 100 people on our list. 100 people. Okay, how many cups of sugar? Yeah, we need to know, can you use what's in there, or do we have to go grocery shopping, right? Okay, so good problem. How do we start? This is where you shrug your shoulders like, I have no idea. Well, think about it. If I said, here, so if numbers like this tend to trip us up sometimes, me too. So I'll make it easier. If I say, you know what, I have a recipe that makes 10 cookies. And I have to, how many times do I have to make that recipe for 100 people? What do you think? You have to make it 10 times. So you just did that calculation. So you think, okay, oh, hang on a second. And each time I do it, it's only 1 cup for my recipe for 10 cookies. 1 cup. If I got to make it 10 times 1 is 10. You just did this problem. The numbers are a little bit different though. They're not as easy as that, right? Okay, so if that ever happens to you, just make the numbers easy. Think about the problem so you do it automatically, and then think about, well, what is it that I'm doing in my head? That's what we want you to get good at. Okay. So question, how many batches do we need? I have no idea. Okay, so how would we find that out? How would we find out how many batches we need to do? Yeah, that's right. Somebody said multiplication. Excellent. All right, so let's figure that out. So 18 times 1, that's easy. That's 18. That's 1 batch. 18 times 2, 36. Okay. So 100 is, this is like 30, right? So I'm going to say, what is 18 times 6? 18 times 6, I'll do the math for you right now. It's 108. Okay, so that might work. Let me just do 18 times 5, which is 90. Okay, so how many batches should we make for 100 people? Which one? Show me with your fingers. 18 times what? What do you think we should do? Some people are saying 5. You will have 10 people that are upset. Yeah, this one, right? You gotta do this one. Okay, so you're gonna have some leftovers, which, for cooking, we like leftovers, right? Smile if you like leftovers. Yeah, me too. Here's my smile. Okay, so we need to make 108 cookies. So how many batches? That is 6 batches. Okay, great. So now we know how many times we got to make the recipe. This is going to be fun, right? Okay. So 6 batches means that for each batch, how much sugar? Do you remember? How much sugar? One batch needs a 1/4 cup sugar, so 0.25. And we got to do that 6 times. So this is my cups of sugar times 6 batches. Okay. So are we multiplying? Are we adding? What are we doing here? We're multiplying. Okay, so this is your big moment. What is 6 times 0.25? How would you do that? Well, since you're already really good at fractions, I might actually turn this into a fraction. I might say, you know what? That's a 1/4, and that's a 6. Which problem looks nicer to do? Well, it depends on what you're comfortable with. So this is 6 times 25, so 25 times 6. And you may already know this one in your head, because 25 times 4 is 100. Add 2 more is 150. And then you put your decimal point back in with 2 hops. So this is $1.50. This is 1.5 cups of sugar. This is 6 on the top, 4 on the bottom, reduces to 3/2, which is also 1.5 cups of sugar. See how we get the same answer? So either way, you have tools now. We get to use them. All right, so that's how much sugar that we need. So for the first one, you can write in all this that I wrote in. How much sugar do we need? We need 1.5 cups total. All right, which means we're going to have to go run into the pantry. So we run in there. And of course, we don't find 1.5 cups measured perfectly. We find a box. We find 2 boxes. The blue box, where's my blue marker here? Blue box is labeled. Whoops, this is a terrible box. I'm sure you could do better. This box is labeled, I have 250.9 grams. And the white box is labeled, what is it labeled as? 1.03. Okay, so which box should we use? The one that says 250 or the one that says 1.03? Careful. Did you look at the units? What are the units on these things? Yeah, this happens in real life. So I tried to make this as realistic as I could. So grams, okay, this is kilograms. Let's convert this to grams so we're talking about the same numbers. So 1.03 kilograms, there are 1 kilogram has 1,000 grams. It's just like going between millimeters and meters. We've done this a lot before, okay, in the last 14 weeks. Okay, 1.03, so like 1 times 1,000 is about 1,000, right? So my answer is 1, and we move this 3 decimal points here. I'll put it here. Here's our decimal point. We're going to go, for these 3 zeros, we're going to go 1, 2, 3. So this box has 1,030 grams in that box. This box has 250.9 grams. Which one has more? Yeah, the one that looked like it didn't. So this one has more. The question is, how many, I don't know, like cups, this is different, right? Cups is not the same as grams. Cups is volume. This is how much space, you'll have a measuring cup, right? And so that's how much space it takes. Grams, this is if you put it on a scale and you weigh it. So do you see how these are 2 different things? You're like, oh, Aurora, this problem is getting worse and worse. I just want to bake the cookies. Okay. So what if I give you one more number? What if I say we need, their sugar is 200 grams per cup. So now we have a way to relate the mass with the volume. Okay, so if I need 1.5 cups of sugar and I multiply by 200 grams per cup, do you see how cups is going to cancel? How many grams of sugar do we need? Okay, and this is true just for sugar. Just for sugar. You're hungry now? Okay, so are we going to multiply? Are we going to divide? What are we doing here with those numbers? Which one? Okay, then go ahead and do it. Okay, so this is a calculation. So I have a 1.5 times a 200. Remember with decimals, this is multiplication. We don't care about the decimal point. What is 15 times 2? Do you know that one? 15 twice? 10 twice is 20 plus 2 5s is 30. So 15 times 2 is 30. Okay. And then I have 2 zeros. So 1.5 times 200. We're going to come in. This is one decimal hop this way. So we're going to come in here. So our decimal point is here. So I have 300 grams of sugar is how much I need. Okay. So I need 300 grams of sugar. Great. So which box? Which box is going to have enough? Does it matter? It does matter, yeah. Is this one? Yeah, you're going to come up short. So we're going to, and in reality, you would just pour this out, right? And use the rest of it and then start this one? Yes, I get that. I get that. Okay. But maybe in a chemistry lab where you have to check out chemicals from a technician, you're not going to want to do this. You're going to say, I don't want to keep running back and forth. And they're going to say, do you want the small container or big? Well, how much do you need? You say, I need 300 grams. They'll go back to their storeroom and say, okay, I'm going to give you the bigger one. Just bring it back. Good. Okay, good. All right, so we know what box we're going to use, so you can put that on your page. Okay, so which one should we use? The white box. Okay. Good. Excellent. All right, it's kind of fun so far. All right, let's see. What do we do now? So the next thing we're going to look at is how much sugar is left after we use it. So if I put this back up here, okay, so we're going to use, we need 300 grams of sugar. This is your big chance. You show me, what do we need? How much sugar is left after we do our calculation? If I put that here, you do your calculation, what do you think? How much sugar is left? Are we adding? Are we subtracting? What are we going to do? What should we do? Okay, and then go ahead and do it. Go ahead and do, yep. Okay, did you get an answer? What did you get for an answer? What did you get? And then we'll compare answers. Okay, all right, it looks like we're getting some answers. Good, good, good. I have not seen the right answer. Okay, so here's how I would do the calculation. I would say that box had 1030, right, grams. I used 300. This is a subtraction problem. Okay, so we have 0. And we have a 3, and then 3 from 10 is 7, okay? But don't forget we had another box in the pantry, right? So it's subtraction and addition. These are G's, just so you know they're not 9s, okay? So I have 980.9 grams of sugar left. Because it just didn't say the box. How much sugar do we have left? We have that. Good. Okay, good. Yeah, so don't let that one get you. Okay, and the last one is, how many batch of cookies will the rest of the sugar make? Can you see how if you had this answer, you're not using all the sugar in the pantry? You'll get a different answer now, won't you? Okay, so for the last one, how many batches can we make? Okay, well, how much sugar does each batch need? Yeah, it was 300 cups of sugar for how many batches? Do you remember? For 6 batches. Right? That's how we started the problem. Okay, so what are we going to do? How do we handle this one? Yep, we're going to do a division problem. Excellent. I see a few of you saying division. Okay, how are we going to do the division? Okay, so for one recipe, though, how much do we need? One recipe. One recipe is this much, right? The 1.5 cups was for 6, okay? So it's this much for one batch, okay? And I want to know, how much is that in grams? Okay, so we're going to convert. We want to know how many grams of sugar do you need for every batch? Okay, so this is how many cups, and this is, well, there are 200 grams for every cup of sugar. Okay, so this is our conversion, okay? So I have 2 times 25, which is 50. And then I have 2 zeros here. And then I'm going to come into, so my answer is 50. So I need 50 grams of sugar per batch. Are we done? Is that the answer? No, that's not the answer. How much sugar do I have available to me? Remember that big number I had? 980.9 grams. All right, addition, subtraction, multiplication, division. This is how much sugar I have in the pantry. This is how much each batch takes, okay? So what do I need to do? I need to know how many batches can I make out of this much sugar. If I were to use all the sugar, how much is that good for? What do you think? I said 300 cups. Sorry about that. Okay, so what do? Yes, I see people saying division. Beautiful. So I'm going to divide how much I have by how much everybody gets, right? It's just like if you had, if you're not seeing this, if I had, 6 marbles and I had 3 people, yeah, well, you're just going to take the 6 marbles divided by the 3, right? So it's the same thing here. So this is how much sugar I have, and this is how much per batch. So this is grams per batch. The grams are going to cancel out, and the batch is going to be in the numerator. So I have 980.9 divided by 50. Okay, and then the numerator goes in here, and the 550 goes here. Okay, 50 goes into 98 once, minus 50. We have a 48. Drop the 0. This goes in 9 times. Well, no, actually, it goes in, 9 times. Minus 450. I have a 3. And then we can drop this down, the 9. Okay, and that's a 6. Don't forget to push the decimal point up. This should be a review by now. Minus 300 is a 9. Okay, so that's enough. So how many batches can we make for real? Would you round that number up or down? What do you think? Yeah, sometimes you need to round up. Sometimes you need to round down. And in the real world, can you make 19.6 batches? I mean, is that easy? No, that's kind of hard. So what would you do? Out of this sugar, are you going to run out of sugar first? Yeah, we don't have enough sugar to round that up to 20. So around 19, you'll just have a little bit of sugar left on the bottom of the box, and that's it. So I would say 19 batches you can get out of that much sugar. And that's it. You did your first problem. Yay! All right, did that seem like, woo, that was a lot harder than what we've been doing so far? Does that feel like it a little bit? Or are you feeling like, hey, this is really making sense? Head nod on either one. Yeah, yay, good. All right. So how about you take a sip of water, because this is a class where I get hungry. Okay, you take a sip of water, and then let's take a look at our next problem. All right, how many of you guys like going to the grocery store? So when I take my kids to the grocery store, we have spelling bees, we have contests. One time I dropped their friends off, well, I was in the store too, and I gave the group $10, and I said, get anything you want. I said, just, here's $10 cash. So of course, could they spend $10 and 1 cent or $10 and 2? Could they go over $10? Nope. Which meant it took them 45 minutes to agree. There were like 3 kids. It took them 45 minutes to agree on what they could get that would maximize the value. Isn't this what you would do? To get the best value for that $10 and the most amount of stuff. So they were individually counting like the crackers and the gummy bears. Oh no, I think they couldn't get junk food. And so and the things that they wanted. And so they realized, like fruit is really expensive. And they only got like a small basket of berries. And so they're like, oh, we're not going to get those. So it was a really fun experience. So, all right. So that was the math part of it. So you and I are going to the grocery store. And by the way, since I have boys that are between the ages of 10 and 21, it feels like I am always at the grocery store. Okay, so here we go. Second problem. You ready? You like it when mom goes to the grocery store? Yeah, I'm sure. Well, let her know. Let her know how much you appreciate it. Okay. All right, we've got apples. We've got bread. We have milk. And I didn't say what kind of chips. So if you're into chocolate chips, that's what those are. If you're into, what do you call them, tortilla chips? Yeah, okay, so we have $2.49. That's not a 49. Hang on a second. I miss chalkboards, I really do. $2.49 for apples. How much was the bread? $2.99. Oh, this is per pound. LB is pound. This is per loaf of bread. Okay. Milk was $5.99 a gallon. This is how much it is, by the way, at my grocery store. And chips are, well, it depends on the chips, really. $4.35 per bag. Okay. All right. Oh, no, I got that chip wrong, didn't I? That's supposed to be I changed the price on this one. This is $3.49. Thank you. So $3.49 per bag. Okay. All right. Shall we? I would like 3 pounds of apples. Okay, 3 pounds of apples. Here's my shopping list. 2 loaves of bread. We're going to make a lot of sandwiches. And 1 gallon of milk. By the way, I am giving a prize to a kid in class today. This is your first opportunity to get your name in the hat. Tell me, how much did I spend? How much did I spend? All right, what am I doing? Addition, subtraction, multiplication, division, screaming? What am I doing? All right, that's right. No calculators yet. You don't graduate till the end of class today, or to the end of class this week. Yes, you do get to start using calculators in our next class in January. Absolutely. All right, this one's by hand because the name of the class is decimals. Okay. All right, so I'm going to take this away so I can do this for students that need a little help. Okay, so apples. Good. I want 3 apples. Did I say 3 apples? No, I want 3 pounds of apples. This is how much it is per pound. So this number gets multiplied by a 3. I want 2 loaves of bread. If it's this much per loaf, doesn't this drive you crazy the way they do this? Why don't they just say $3? That would make it so much easier, right? But then it looks more, doesn't it? $3. This looks much more expensive than that. So that's why they do that. All right, so this one, we're going to multiply it by a 2. And we don't actually need chips this time. Maybe we have some already. And this is just as is. Okay, so the problem, let's set up the problem. It's $2.49. And if you guys could give me the prices, then I'll just write in your answers here. And one at $5.99. You want to do the $5.99 one? That's funny. All right, $5.99. I'm going to do that one. There. Okay, $2.99. What I would do is I would say this is a penny off. So I would say $3 times 2 is $6, and then subtract 2 pennies. So that would be $6 minus 2 pennies is $5.98. So that's how I would do that one in my head. This one is $2.50 3 times. Well, since we're in decimals, let's just do it. So $2.49 times 3. So ignore the decimal point, and we're just going to multiply these out. So that's 27. So this is 12.14. Okay, and then we have a 7. Decimal point comes in 2 places, 1, 2. So it's 7.47. Okay. All right, and now we are going to, so this was a multiplication first, and then an addition. Okay, so this is a 7. Okay, so we're going to add up each of the columns, and I'm seeing some correct answers already. Seeing some correct answers. I see. If you are ready for the answer and you want to check it, look up here. I'm not going to say it out loud in case you're still working. Okay, but this was not the answer to the problem. The answer says, how much is our change if I pay with $20? How much is our change? Okay. So we had 3 operations in this one. We had multiplication first, then we had addition. We added these together. And now what do we have? Yeah, we have subtraction, don't we? We have a 20 minus the bill. Okay, let's zoom out just a little bit. Yeah, this decimal thing is all over the place, isn't it? Yeah, that's a 7. Somebody was asking. Yeah, 7, good. What do you get? No, I don't see a correct answer yet. $1.56. Where are you guys getting if I have $19.44 and I am only paying with a 20, can you see how it has to be less than $1? My change is less than $1, right? Because I've already passed the 19 point. So how much is my change? Yeah, so when you borrow, let me do this one. So you're going to borrow here, so that's a 6. But then you cross off the 200 and you write 199er. Remember that? But this one here is a 10, this 1 and 0. So this is a 5, and then you have 0. My change is this, or you can write it this way. Okay, but you wouldn't combine the 2 symbols. By the way, somebody was asking about the dollar sign. For US dollar, originally it was US. That's why it looks like that. But nobody connects the bottom, and they just go like this. All right. Good, yay! So how'd you feel about this one? Put a smile on your face so I can see that you're good with this. Are you good? I love that, perfect, beautiful. I love all the smiles. Okay, if you have questions, you're letting me know. I'm trying to, I see lots of teeth now. Okay, those are scary smiles. My goodness, it looks like if I was next to you right now, I would say you're up to something. Okay, okay, good. I've got your name and a hat, we're good. Shall we continue? All right, this next problem is from it's actually from a story that I was telling somebody. It was a parent who was worried that their kid was spending too much time on watching TV. And I said, well, how much time do they spend watching TV? Like, is this really a concern, or is it just the parent, right? Okay. Oh, make sure you only put your answer in once, MLR. Otherwise, you make it hard for me to go back. Okay. And so she says, my kid watches 9 to 10 hours of TV a day. And I was like, so movies, computer time, that kind of thing. So media. And I'm like, 9 to 10 hours a day, does that seem like a lot to you? I sleep that much. That doesn't seem like a lot? Okay. So then I told her this story. And this is the problem we're going to be doing now. Ready? This one is about Olympic athletes. They train on average 10,000 hours. That seems like a lot of hours, doesn't it? It's a lot of hours. It is. That's the reason that they're Olympians, right? The best athletes in the world. They train for 10,000 hours over a period of 7 years. Okay, so keep this. These are 2 different things, right? So this amount of time over this many years. Okay, so we have 2 times in here. How many hours a day do they train? So they're going to train 6 days a week. They get 1 day off for recovery. Okay. And not all of them do this, but some of them will also take a week off for spring break and a week off for winter break. So they will take 2 weeks off each year. Okay. That seems pretty reasonable, right? I want to be the best, one of the best in the world. It's going to take some dedication. All right, so let's find out exactly how much dedication. So, by the way, these are real numbers. Real numbers. Okay. So, what is your first guess? Like, what do you think we should do? I want to know how many days a week, how many hours a week they train, or even how many hours a day. Okay. How many hours a day do they train? Well, I know how many hours a year. Could I start with that maybe? Okay. So here's what I might suggest. Can I take this away? You guys have this information now? Yeah? Okay. So I'm thinking if we have 10,000 hours per year. Is it per year? No. What is it? Per 7 years, right? That's our rate. So every 7 years, they train 10,000 hours. Okay, let's convert this into weeks. So there is 1 year. How many weeks in a year? Oh, be careful. Are they training every week in the year? No, so you have to adjust that number. For those of you who don't know, there are 52 weeks per year. Okay, in case that was new for you. All right, so this is 52 weeks a year. So are they training 52 weeks a year? How many are they really training? Yeah, they're training 52 minus 2, so you can do that one in your head. That's 50 weeks in an athlete year. Okay, so if they train 50 weeks in their year. Okay, so we're adjusting this. Okay, so their year is really only 50 weeks long. Great, years cancel. Okay, so we're going to take 10,000 divided by 50. I'm going to do this one for you because I want you to focus on the next part of the problem. Can I do this division for you? Are you guys okay? So 10,000 divided by 7 divided by 50. Okay, so this becomes 10,000. 7 times 5 is 35. Here's my other 0. Okay, so this is the number part, and this is going to be hours per weeks. Okay. All right, so let me work on this division so that this goes in the top, 10,000. 350 goes out here. So 350 times 1 is 350. 350 times 2, that's 700. 350 times 3 is 1050. Okay. All right, so you see how we're going to use the 2 here? And I'm going to put it right above this one. Okay. Wait, did I put it? Nope, I put it on the wrong one. There's a lot of zeros in this one, so I wanted to make sure I got it right. Okay, so I put it on this one. 350 goes into 1,000 2 times, so I'm going to minus 700. This is where grid paper comes in handy. Okay, all right, and then I've got 300, which is not big enough, so we drop that 0. Okay, so that 350, okay, it actually goes in 8 times. Okay, all right, and then 350 times 8 is 2,800. Help me with my subtraction. Oh, sorry, you can't see that. Okay, good, so I have 200. All right, so now we're going to put a decimal point, and we're going to add the other 0. Whoops, which is right there. 350 into 2,000. So I'm going to say that is going to be, I think, 5. So push up the decimal point. Okay. This is 1,750. Okay. And then we're going to do some subtraction. I get 250 out. I'll do one more 0. One more 0 here. And so I have 350, and if I multiply it by, let me think. 50, I think it's 7. I get 2450. Okay. All right, so big, long division problem. Yeah, you guys probably beat me to the answer, didn't you? Great. So what does that number mean? Okay, so that number means we have this many hours that they train every week. So how do we change that to days? So let's write it down. So we have 28 and 57/100 hours per week. How many hours are in a week? I don't know. Let's find out. So what are we going to need to do? Can we round this number up, actually? Let me do this differently. Let's round that up. So 2857. Let's round that up to 29. This is hours per week. Let's make this easier for us. Okay. How many hours per week? Good. So we have 29. Okay, how many days a week do they train? 7, are you sure? So we have 29 hours per week divided by, that's right, 6 days a week, right? Divided by 6 days per week, okay? So that means it's 29 hours per week. So, and we're going to divide it by, week is on the top, days is on the bottom. Okay. And you see how our weeks cancel? Now we have hours per day. Hours per day. I get 4.8 hours every day. So they train about 5 hours a day. Question. How many hours was that kid watching media for every day? 10. What does that mean? If he even took half that amount of time and put it into a sport that he or she really loved, you could in 7 years be at Olympic level. Doesn't that blow your mind? The kid was like, no way. But it's got to be something that you love, that you're passionate about, right? Otherwise, you're just doing the same hour 10,000 times. So if it was just half that time, right? Doesn't that just make you just go, what? I wonder what else I could do. So one of the secrets one of my teachers taught me was that people overestimate what they can do in a year, and they seriously underestimate what they can do in 10 or 5 or 10 long term. Just because we don't have the ability to see long term as easily as short term. Short term is here now. I can see it. I can feel it. I can breathe it. Yeah. But long term, I don't know. It's kind of hard to imagine, right? How old are you guys right now? Like, show me with your hands, or you can type it in. All right, now double that. So when you double that, most of you will be driving, maybe going to college, right? Working jobs. You'll be having an income. So there'll be like, there's a lot of stuff you got to do, right? You'll be doing your own laundry. All right, so I thought that was a good exercise. Like, whoa, I wonder what else is possible. All right. Okay, so I would love to know if you're up for a road trip. Anyone up for a road trip? All right. This is your second and final chance to get entered in, and I'm gonna pick a prize winner. You're gonna help me with my calculations. Can you help me? Excellent. Let's take a look at the problem. We are going from New York to San Francisco, okay? Where do you want to live? Which one? I'll live in the other place. Okay, so we're going to go from your house to mine. I see some people say New York and some people saying San Francisco. Okay, perfect. So just pick one and then I'll be the other one. Okay, great. So I would like to take a road trip, and question is, this is 2,700 miles by road. Oh, miles. Okay. All right. I want to know, how much gas are we going to use? Because I need to make sure we have enough money. It'd be a bummer to start this trip and then, get stuck in, I don't know, only get partway there and then have to work and yeah. So we want to do it all. What kind of information do you need from me? I'm going to tell you I have one of these really super popular Toyota RAV4s. You tell me, what kind of information do you need about my car to make this calculation? What would you ask me for? I can give you anything because I got the owner's manual. Okay, so you tell me, what information do you need? What do you want to know? And then I'll answer that. How many miles is the trip? Okay, it's right here. The trip is 2,700 miles. That's how far we got to go. You want to know how many seat belts? Okay. Does it matter if the car has one person or 5? Will it change the amount of gas? Not a whole lot. So don't worry about that one. That's you're thinking about weight. Okay. So think there's another number you need. There we go. I'm getting it. Is it electric? No, it's not. What is the miles per gallon? Excellent. I have 30 miles per gallon of gas. Okay. You want to know what the range is? Okay, sure. Range, but it depends on the type of driving you do, right? Same with the miles per gas. 435 miles. You want to know how much gas is in the gas tank? No problem. 14.5 gallons. You want to know tire pressure? Okay, sure. The front tire is probably the same as my Pilot. So 30, I think it's 36 PSI in the front and the back. 32 to 36 PSI tire pressure, sure. All right, what else do you want to know? What do you think you're going to need for this calculation? Do you think you have enough? How much gas does it use per mile? Ooh, how would you get that? How much gas? Yeah, okay, you could take this number and flip it. That would be gas per mile. Yep, so 1 over 30. Good. Okay, great. How many snacks? Okay, let's hang on a second. We know we're going to go and get to a gas station, right? We know we're going to run in and get the snacks. So assume we're going to do that. Let's find out, well, how do we do? Okay, so we're good? Okay, so which number are we going to use first? There's, based on the numbers you asked me for, not tire pressure, we don't need that here. Okay, based on these numbers, you can do this calculation in one of 2 ways. So there's 2 different ways of doing it based on what you asked me for. So this is excellent. Okay, let's talk about the first one. Let's do this one first, and then we'll talk about the person that asked for this. Okay, so here we go. How far do we want to go? We want to go from here to here, New York, San Francisco. Okay, and this is 2,700 miles. Okay, I want to know how far will each tank of gas get me? Okay, so how many gallons is this going to take me? 2,700 miles over 30 miles per gallon. Okay, that means 2,700 miles divided by, or not divided here. Well, here, sure, divided by 30 miles per gallon. And then to change it from a multiplication to division to multiplication, remember what we do? We take 2,700 miles and we multiply by the reciprocal. So whatever's on top goes on the bottom. Yep, same for units. So miles is going to cancel out and I'll have gallons. 2,700 divided by 30. What is 27 divided by 3? 27 over 3? You guys remember your multiplication table? Yeah, good, 9. Okay, and then here, maybe this would help. 2,700 over 30. One of the zeros cancels. 3 into 27, this is 9 times 3. So one of the 3's goes away. 9 times the 10 here, which is 90. So this is how many gallons of gas it's going to take to go from New York to San Francisco. So this is going to take 90 gallons of gas. That's a lot of gas. Okay, so our tank can hold this much, 14.5. So let's say it's about 14. Okay, so our tank can hold 14. Well, you know what? You can do it in your head if I make it 15. Can we bump it up to 15? We'll just put a little factor in there. Okay. All right. So you want me to do 14.5. Okay. All right. Fair enough. I will do 14.5. Gallons over 14.5. And your parents know that you do not use all of the gas. And if you do, you are very quickly on the side of the road. All right. So usually you'll fill up around 13, 13 and a half, maybe 14 if you're on fumes. But rarely, you don't ever really go down. Okay, so this goes in here, 14.5. All right, how do we do this problem? Do you remember? So we have to make this a whole number. So we take that and go one hop, which means we have to adjust this as well. So we're multiplying top and bottom. What we're doing is multiplying top and bottom by 10. But you can't just multiply the bottom because then that changes the problem. So you have to do top and bottom. So multiply this by 10, that's 145. Multiply the 90 by 10, that is 900. Okay, let's see. 145 times 5, I'll give you a little multiplication table here. 725. 145 times 6 is 870. 145 times 7 is 1015. All right, who do you want to use? Which one? Which one goes on top? Now this one's good, better, oops. Okay, so this is going to be right over this part, the ones. Okay, minus 870, and we have 30 left over. Decimal point goes here, push it up. Okay, drop the 0 down, we have 300. Oh, here, 145 times, you know what it is, times 1. Times 2 is 2, do you know what 145 times 2 is? 290. Okay, so minus 290 is 10, and that's enough for me. So this is a 2. Okay, what is this? What is this number? 6.2 what? All right, write it in the chat. What's my what am I calculating? Yep, gallons is going to cancel out. Good. Gallons cancels out. Tank goes to the top. This is how many tanks of gas we need. Okay. Just look at the original calculation. It's easy to get in here and you're like, wait, what did I just calculate? So go back to the original problem. Okay. This is 90 divided by 14.5. That was this problem that we redid. Gallons cancels. Tank goes to the top. So this is how many tanks of fuel we need. So our trip is going to take 6.2. So in 90 gallons, 6.2 tanks of gas. Can you go to the gas station and say, I'd like 0.2 tanks of gas? Well, you can. That's what you do when we're first starting out and you don't have a lot of money. You just fill up like $10 worth of gas, which back when I was learning actually got you some gas. Today, it's probably not as much. Okay, so this is how many tanks of gas we're going to need. So I'm going to say we need 7 tanks of gas. Would you agree? Yeah. So that's going to round up to 7 tanks. Okay, so we're going New York to San Francisco. So 7 tanks of gas. So that means 6 snack stops, depending on if you start full or not. 6 or 7 snack stops. Somebody kept asking me, how many snacks? Good. Okay. Does that answer our question? No. All right. How much is gas where you live? How much is gas where you live right now? Can you put it in the chat and I'll just grab one of your numbers? All right, we need 90 gallons. Let's find out how much this trip is going to cost us. 90 gallons. Let's go back to the 90. 90 gallons. Okay. That's how much gas we need. Okay, here we go. Wow, okay, 90 gallons. And then our tank, here, let me just do it by the tank. Okay, our tank holds 14.5 gallons. Okay, let's round that to 14. All right, I'm going to grab a number. Wow, I'm going to move to where you guys are because my gas is a lot. Anybody have it more expensive than this? Per gallon? Yeah, okay. So this is actually cheap for me right now. My gallon tank of I saw it as $6.33 yesterday per gallon of gas. I know, isn't that crazy? Okay, so somebody put in $5.05, okay, and we have 14 gallons of gas, okay, and because it's a decimal class, you get to do the fun part. We're going to multiply this together, so this is how much, $5.05 per gallon of gas. A full tank, when it's completely dry, 14.5 on my little rev. If I tell you this is the multiplication, can you put the decimal point in? Where does the decimal point go? How much is it to fill up my tank one time? This is how much it is for one tank of gas. This is how much it is per gallon. Okay, so where does, wow, $700 per gallon of per tank of gas. Check your decimal point there. Okay, so I have 1, 2, 3. So it's 1, 2, 3. Did you guys get it? All right, so it's going to cost us $73.23 every time we fill up. How many times are we filling up? 7, right? We need 7 tanks of gas. Good. Here, I'll give you the final. How much money are we going to spend on gas? Can you put in the decimal point for me? Yeah, this is tanks. Here, I'll write the units in. 7 tanks. This is per tank. Okay. Good. How much do we need? This is just to get us there. $512.58. We are going across the country. Yes, we are going across the country. And maybe we'll take a few side trips and so forth. Good. Okay. How was that for a calculation? All right, so it's going to cost us $512.58. We'll call it $513. Of course, the price of gas is going to change as we travel, right? So they're not all going to be the same price, but about that much. Good. The other way to do this problem, somebody had asked for the range. And that's actually a good question. You could take 2,700, divide it by this, and that will tell you how many miles you will get, how many chunks you have to go before you have to fill up again. And this will also give you the tanks of gas, right? Because you can go this on one tank. This is 1 tank of gas. Good. Gives you that far. So that's another way to do it. You'll get the same answer if you're careful with your calculations. Somebody's asking a good question. Does it matter how many people we take? Yes. If it's one trip, 513, you tell me, do you want to just go solo or do you want to take as many friends as you can who all can contribute to gas money? Yeah, more friends, right? Because that's more fun too. The right friends. I would agree with that. Somebody said the right friends. Good. So if it's just you and me, $513, we each have to pay half, right? So that may be $256-ish. But what if we take 5 people? There are 5 seatbelts in there. All right, set up the problem. What does it look like? And then show me on the screen, those of you who are on Zoom. You want to see me do it with the range calculation. Okay, so set up the problem for 5 people. Here's the quick range calculation. 435 miles, okay, is on the bottom. 2,700 is on the top. When you do this, you get 6.2 tanks of fuel. Or tanks of gas. Okay, that's the calculation from before. All right, set up the problem. How do you do this? If we don't have 2, but we have 5, what does the division look like? Put the number in the box and outside. What does it look like? Okay, so I have a 513 in here, and I have a 5 out here. Did you get it? Now, extra credit. Who did the actual division? Can you beat me to it? Here, I'm not going to say anything in case you're working. All right, so you tell me, would you rather pay the top number in red or the bottom number in blue? It depends. You know, sometimes just a road trip with 2 people is really cool, but it is more expensive, right? It is more expensive. Less people contributing. All right, did you get it? Yay! And it depends. You know, my daughter and I just had a road trip, just the two of us, over the summer, and it was super fun. We went to bookstores. We went and test drove as many hot cocoa shops as we could find. It was totally fun. And then we went with all 6 of us, and that's a lot of people in one car. That only has 8 seatbelts. Not only, but it does, including all of our camping gear and all of our stuff. And yeah, it was a lot. But different kind of trip, right? So yay! All right, we did it. We did a road trip for $100. We went from New York to San Francisco, and we spent $100 on. By the way, is that round trip or one way? One way. So if you want to go back home, what do you have to do to that number? Here, let me put the number back up. What do you have to do to the number? Yeah, okay. All right. We are at the end of our hour, and you know what? I have to start the other class because they're going to be coming in 3 minutes. Here's what I'm going to do. I'm going to give you guys an extra story at the party. Can I do that? Can I do a little extra story? Yes, yes, yes. All right. So yay, we did it. We kind of had little stories throughout this one. So yay. All right. Those of you who are joining me for my party, I can't wait. It's going to be a whole lot of fun. We are going to have a party on Wednesday at 4 p.m. Pacific. So at 7 p.m. Eastern. Come join me. It's going to be fun. You bring the popcorn. I'll bring the math problems. We're going to review everything we've done in decimals. We're going to play a game, Escape the Classroom. There is a handout. You need it. I sent it to you by email. If you have questions, let me know. Aurora at superchargedscience.com. I hope you had fun, and I will see you in the next session. Bye-bye, everybody.